Alright, here we are with 6.2, just one day. Topic is the law of cosines, which aims to solve pretty similar problems, really similar actually, that we did with the law of sines. It's just these are a set of formulas that use the cosine function as opposed to the sine function. Okay, here they are. So let me kind of take you through what's going on. Unlike the law of sines, I'm not going to show you the derivation for the law of cosines. It's longer. It's significantly more complicated. But it's out there, so it's kind of like we did with the law of sines. In theory, we really should go through and look at kind of a diagram of an arbitrary triangle to prove that these formulas are legit. We did it for the law of sines. We're not going to do it here. Over on the left side, remember, big letters are angles, little letters are sides, and the matching pairs are always opposite, like the diagram shows. You can use the law of cosines in the SAS case to get a side, okay, and there you can see it on the left. Or if you have the side, side, side case, you can use it to get angles. I'll show you both. Okay, those are the two cases in which they come up. Side, angle, side, and side, side, side. That's why we have these marked. So really what you've got here, and they don't look as nice as the law of sines, just keep in mind that the law of cosines is going to be fairly calculator heavy. The big part, well, there's really two parts. Pick the right form that'll work for the problem that you're doing, whether it's you're solving for a side or an angle. You've got both sets. And then get the numbers plugged in where they go. From there, because the formulas are a little bit yucky, right? There's a lot going on with them. Calculator's going to do the rest. All right, good one to start on. Got a triangle. Let's solve it. Let's go back to our case. One of the easier cases to identify that we have S, S, S. Okay? So what I'm going to do is the law of cosines twice. That'll get us both angles. We don't need to do it 3 times because once we have, two angles in a triangle, you essentially have the third. I am going to start with B. Okay, now you got to be a little bit careful that when you use the formula of cosine of B, you'll probably notice this when you plug everything in. This formula won't directly give you your angle, it'll give you the cosine value. Alright, so now as I'm plugging in stuff where it belongs, I've got 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14. All of this can go in your calculator at once as long as you put parentheses around the top and on the bottom. Okay? Remember, with a fraction, parentheses are always implied. Whether they're not written there, but in reality they always are. If you don't put the parentheses and you throw it all in at once, you will get the wrong cosine value. So be careful about that. Obviously, I can't show you the calculator part of it, but I will give you the answer. If you have a calculator with inverse, well, we'll get to the inverse trig function in a minute. Just a calculator in general, you should be double checking as you go through these. For this one, you should make sure that you get negative 0.45. This is where you would do the inverse, and you get that angle B is 116.8 degrees, which would be right here. Now I've kind of I've talked about the cases with the law of cosines, but as far as how it kind of relates to the law of sines, because they kind of do the same thing, you can memorize the two cases that the law of cosines will work for side angle side and side side side. That's one way to do it. The other thing is here, if you had tried to find angle B with the law of sines, you would see that it just wouldn't work. You know, you've got 4 things to put in the law of sines. You would have 2 that are missing, and it's just not going to work. Okay, that's one approach you could try is, if you can't remember the cases, try the law of sines first. You won't have any luck, and if that's what happens, then go and move on to the law of cosines. For A, now one other thing you might notice, after we found A, could you use the law of sines? You could. Okay, you could. You would have to use the law of cosines to get the first angle here. Beyond that, I mean, this lesson is on the law of cosines, so that's all I'm going to use. But at this point, for angle A, law of sines, law of cosines, I don't really care which you use. I like to avoid the law of sines because remember how it has that ambiguous case? You're probably thinking back to 6-1 day 2, and you're like, yeah, I remember that ambiguous case. I don't like it, right? It's confusing. It's complicated. Law of cosines doesn't have that ambiguous case. That whole thing comes up because of a situation with the sine function, but that same thing doesn't happen with the cosine function. So I typically take the approach, if I can use the law of cosines, I do. Just more straightforward. Number crunch all of that. Let's just go back to your list of formulas. That's if I'm looking for the cosine of A. Everything is getting plugged in where it belongs. Inverse cosine of 0.927 gives you 22.1 degrees. Theoretically, we certainly could do the law of cosines again. That would not be a wise thing to do. 180 minus 116.8 minus 22.1. We've got our third angle. All right, here's another one. No context to it. Just, hey, here's a triangle. Solve it. So again, a couple approaches you could take here. You could dive in and try something. If you tried the law of sines, you're going to see it's not going to work. It's a side angle side case. You're not going to have any luck. Hate to say it, but you're just not. Because it's a particular case that requires the law of cosines. And as a matter of fact, let's go and dive right in. And let's get A, the only side that's missing. This is going to be another one where I'm going to use 2, 1 to get an side, and 1 to get an angle. So if I'm looking for A, all right, notice I have all my parts labeled. And so I'm going to that list of formulas that I gave you, and I'm just saying, all right, I've got the form that's for A squared. All right, so B squared plus C squared minus 2 times B times C times the cosine of A. There you go. Be careful with this. When you number crunch all this, you'll get 451.59. That's not A. That's A squared. So you got to do a square root, and you get 21.3 centimeters. And there you go. Okay, we've got our third and final missing side. Our only missing side, I should say. But we're not done, because the instructions here are to solve the triangle. We've got 2 angles that are missing. You can take your pick, C or B. At this point, it really doesn't matter. You could use law of cosines to get either one. I'm going to go get B, just because. So I would check my form that's for cosine of B, and I would see 21.3 squared. plus 10 squared minus 15 squared over 2 times 21.3 times 10. Okay. Throw all that in to a calculator. Make sure you got parentheses around the top and the bottom. And you're going to get about 0.772, which will mean that angle B, when we do the inverse, is going to be about 39.5 degrees. So we just found that. 180 minus 115 minus 39.5, 25.5, and there you go. Triangle solved. All right, two little application questions. You know right off the bat here, they're both going to use the law of cosines. Got a diagram to help us out, but here's what we're after. Pitching mound on a softball field is right there. And this problem tells us that from there to home plate is about 43 feet. Home to first is 60 feet. Okay, now one thing I probably would have told you had this been like a test question. This is a little bit tricky, and I wouldn't necessarily expect you to get it with the lack of context on a softball field. But that angle that forms between the pitcher's mound and first base is 45 degrees. Okay, because when we have that, you can all of a sudden see, you know, wait a minute, this is the SAS case. We have two sides. We know the angle in between. If we didn't have that angle and we had two sides, we got nowhere to go. We don't have the information we need to answer this question of how far is it from the pitcher's mound to first base. Okay. It doesn't matter here what letter I call what I'm trying to find. Okay. I think it's best if you just give it one of them. But here's what you just have to keep in mind. If I say that what I'm looking for is side length A, there's angle A, and then this doesn't matter. 43, let's say that's B, and 60 is side length C. Those two that I know could be interchanged. It's not going to make a difference. But that's probably the best way to go, is to just name it, and then go back to your list of formulas and just find the one that fits how you name the sides and the angles. I have to drop down here a little bit. Kind of ran out of room. This you don't have to be as careful as, remember with when you were using the formula to find an angle and you had like the fraction. And I said you got to be really careful to make sure you have parentheses around the top and the bottom. This form you really don't. You can just type that in as you see it, and you're going to get 1800.33. Take a nice little square root, and you get 42.43 feet. Final answer, again, that was the distance from here on the pitcher's mound over to first base. All right, last one. Okay, last one here. Right off the bat, before we even get to the context, because I want to make sure you're thinking about this, because you might not be, because you know it's the law of cosines, but when you get to, quizzes and tests, I'm going to lump these all together and not tell you what section that it's from, and you've got to identify. This problem gives you information about side, side, side. Okay, you have all three sides, you don't know anything about an angle. That is a law of cosines case. Okay, that's why I'm going to take this approach. So here's the deal. From point B to point C, it gives us all this information about the race. All right, if I'm at point B, that's due north. This angle right here tells me what we call the directional bearing from point B to point C. Okay, so here's how the form of my answer is going to go. I'm facing north, and really what I got to figure out is how many degrees to the east would we need to rotate. Okay, think of this, north is the direction that we're facing to start, and then rotate, in this case, clockwise. And I've got the angle mark that we're after. All right. Now that gets a little bit tricky because you might be thinking, well, how? That's not technically in this big triangle that's formed. That's not one of the angles. Here's the approach I'm going to take. I'm going to use this form of the law of cosines, and I'm just going to get angle B. This whole thing. All right? Remember, this directional bearing that I drew in represents due north. So the angle on the left side of it is 90 degrees. Okay? That would be this angle right here. Okay? That's 90 degrees. So essentially what's going to happen here is I'm going to use the law of cosines, and then I just need to take away 90 from my answer. All right? So a couple things about expectations in terms of what I'm going to get. When I use the law of cosines to get angle B, I'm expecting a big angle, right? It looks like it's almost 180 degrees. Okay, and again, that's the whole thing. All right? When I look at the directional bearing relative to north, that's the angle that I've drawn in red. It looks to be a little bit less than 90. So I'm thinking, when I do the law of cosines, I'm going to get something that's like 160 to 170, and then that would put my final answer, after I take away 90, to like 70 or 80 degrees. All right, but here's what we would have for B. And this part really is the key. If you can take your time and make sure that all these numbers, all these side lengths, just get where they belong, you're probably going to have good success. This is the case where you got to be careful. That top and the bottom needs to go in parentheses. And you get that. Do inverse cosine, and remember, this is the angle, the whole thing, which I was expecting to be pretty big, because the angle that I just found is technically this. There, and then there. Okay? But the directional bearing, that's what we want, is relative to north. So I'm going to take 166.15, and those 90 degrees on the left side of the direction pointing north, I don't want, which gives us 76.15. Okay, which would tell you for that last part of the course that the ship is traveling on, it is going in a direction. If you were to face north and then you were to turn to the east just over 76 degrees, that would put you on the direction that the ship is going.